Hello and welcome. Myself, Professor Vikash Katariya. Today's is lecture number 6, subject code 3630003, subject name operating system. Topic which is going to cover in this lecture: process, differences between process and program, and finally we will discuss on process control block. Let's have a discussion. Let's start with the term process. An instance of a program is called process. An active entity of program at the time of execution is called process. Thus, a single process consists of followings. First, a program in execution, an instance of a program running on a computer, the entity that can be assigned to and executed on a processor. Right? So here very clear the term process. Anytime if user wants to execute their program exists on the hard disk or any secondary device, at the time of execution that program become the process. That is why we are saying here an instance of program is called process, because it is activate into the primary memory. All context of the process present in the primary memory and it is keep continuing executing. That is why it is called active entity. Right? There are two essential of process. Basically that is essential components of process. Two essential components of process are: first is program code and second a set of data. Right? Let's talk about some difference between process and program. Program, as we know that it is a set of instruction written to solve a problem. So program is nothing, just a set of instruction, set of code written in any language to solve any particular problem. Where process, it is a program at the time of execution. So program in execution is called a process. Second difference, program it is a passive entity such as a file stored on a disk. So we created so many files, we stored that file to the disk, that become the program. It is stored in a hard disk and it is not active at the time. Okay, so that is why I'm saying here the passive entity, not currently activated, because it is stored in a hard disk. Right? Where it is an active process, it is an active entity as a number of resources are associated with it. Okay, so process is an active entity because at the time of executing the process it is quite possible process may engage number of resources. Right? May some files, some data structure, some input devices, maybe some output devices. Right? So it is an active entity as a number of resources are associated with it. Third difference, a program is a single entity in itself. We create single program at a time. So itself it is a single entity. Okay, we cannot create more than one program at the same time. Where process, two or more processes may be associated with the same program. It is possible. Right? Next difference, programs are present usually in a secondary memory. As I told you, I create a program. Right? I created a program stored into the location, suppose D drive. So programs are present usually in secondary memory, where process are found mostly into the primary memory. Okay, because at the time of execution program becomes the process, so process mostly found in primary memory. So that is about the location of program and process. program always found into the secondary memory and the process mostly found into the primary memory. Next difference, program remains in the same state throughout its lifetime, right? So once you created a program, it is stored into the hard disk, and entire lifetime, throughout the lifetime, they don't change the state, right? It's always remain in the same state, whereas process may vary one of the state amongst five. So we have five state in terms of process. It may be new state, ready state, running, waiting, and terminated. So process can be belongs in any one of them in this state. So process continues to change its state among five possible states: new, ready, running, waiting, terminated. Right. Next difference, program is represented on the disk by its name. The meaning is clear. Anytime when I created a program, I would like to keep some name of my program, so that the easily I can find my program, where I write and where I wrote the program and where I stored the program. So I would like to search my file by keeping some name, right? Whereas a process is represented in the primary memory by its PCB. So as you created a program, put the name of that program and it will store onto the disk. In the same way, operating system create a process, put the name into the PCB, and as including name and entire detail of the process will also maintain into the PCB. There are so many information regarding process will be stored into the PCB block, process control block. We will discuss on the later what is PCB exactly. Next difference, program number of programs on disk are limited by size of disk. So the number of programs can be depends upon the size of the disk. If we have greater size of disk, we can have number of programs. We can create number of programs onto the disk. In the same way, process will be depend on the size of primary memory. How many process we are running into the primary memory. So it depends on the size of primary memory or RAM. So program based on the size of disk and the process based on the size of primary memory. Okay, so these are difference between process and program, how it differ from each other. Let's talk about the process control block. As I told you, when program become the process, at the time of execution program become the process. Program situated at hard disk have some name. At the time of execution, that program comes with all context into the primary memory. Operating system create a new process, associate one PCB to each process, right, and put the entire detail of process into the PCB block. So all of the information needed to keep tracks of a process when switching is kept in data package called a process control block, because CPU required entire detail for completion of the execution of the process. If processor do not have any such requirements, CPU cannot able to execute the process. So CPU must have entire detail of the process. So it deal directly with the PCB. PCB contain all the information regarding process. The process control block typically contains following information. First, identifier. It is nothing, just a unique ID. At the time of creating the process, operating system provide a unique ID to a process, which is known as PID, process ID. So it become the identifier. for the operating system. A unique ID to distinguish it from all other the process, right? As we have different names, so our name will differ to some other person. In the same way, in the primary memory we have number of processes. Every process has its own PID, process ID, and operating system recognize all the process to its from its PID, and that is the identifier for operating system. Second, state. The information about the state should be maintained into the PCB. State, that means I am talking about the different 5 states. So process may have 5 states like new, ready, running, waiting, and terminated, and process maybe belongs to any one of the process, any one of the states. So it will contain the current information, current states of the process. Okay. Third important thing is priority. Every process may carry with some priority. Maybe the process belongs to the lower priority, and maybe process belongs to the higher priority. So priority is nothing, just a decimal number associated with the process. So at the time of creating the process, we are assigning a decimal value vary from 0 to 5, which is said to be a priority of the process. Priority, I'm setting the priority because the intention of setting the priority is I want to execute my process first. Okay, so vary from 0 to 5. Lower value contain the higher priority, and higher value contain the lower priority. Okay, 0 means higher priority, 5 means lower priority. We cannot put exceed from the 5. We cannot put any decimal which exceeds from the 5. So the maximum value is 5, that means lower priority. Next information, program counter. At the time of execution of the process may contain number of instruction. Every instruction must have the address. It will be stored into a valid address, which is in hexadecimal notations, into the primary memory. So PCB contain a program counter, which is nothing, just a register which contain the address of next instruction of currently executing process. So process, suppose P1 is currently executing. P1 contain the number of statement is suppose 10. 5 number of statement is currently executing. So PC counter contain the address of number 6 address. Okay, so next instruction is number 6. So it will contain the address of next instruction. So program counter is nothing, just address. It's a register which contain the address of next instruction to be executed for the current process. CPU register. So it is also possible that at the time of execution process may uses different registers of CPU. It is a very fast storage device. Every processor have its own internal register which is uses by the CPU itself for the better utilization of the CPU. It is very fast memory. So CPU, the registers vary in number of types depending on the computer architecture. Maybe they can use the accumulator register, index register, stack pointer, and general purpose register. For any arithmetic calculation, we would like to prefer the accumulator register. For pointing any index of the array, we use the index register. Suppose any time if we suppose the calculation of array, it is the based on index, right? We want to access element from the particular index of the array, so we need an index register in order to perform this task. Stack pointer, that means anytime if we are pointing a stack region into the primary memory, we need a stack pointer, and many more general purpose register we can have. So CPU registers can have accumulator register, index register, stack pointer, and general purpose register. CPU will used based on their architecture of the operating system and the nature of the CPU. CPU can be used any one of the register. Okay. CPU scheduling information. This information includes a process priority, as I told you, the pointer to scheduling queues, and any other scheduling parameters. So what kind of scheduling we are applying to the process, that will be maintained into the PCB block. Maybe we are applying FCFS manner. We want to execute the process in shortage of first manner. Okay, SRTN manner, shortest remaining time next. Right. So whatever, it doesn't matter what kind of scheduling algorithm we are applying to the process, it will take care by the PCB block. Okay. Memory management information, that means the base register. There are two kind of register used for management of the memory. Base register, which contain the base address of the segment. Limit register contains the number of bytes in size. Okay, this is actually two register used for managing the memory. Accounting information, this will contain the information like amount of CPU. Okay, real time used, time limits, account numbers, jobs, how many jobs we have, how many processes numbers we have, how many times CPU will be allocated to a process, what is the latency time, a delay variation, switching time. That all information, it includes all information, so everything should be accountable. Right. And the final is input output status information. Maybe process required some input devices or output devices or any resources like files. Okay, so this information includes the list of input output devices allocated to the process, a list of open files, and so on. So resources doesn't mean that only input output devices treated as the resources. This is not true. Number of open files also treated as a resources. So PCB also contain the input output status, what kind of input output resources engaged by the process. Right, this is what the PCB, process control block. Okay, in the next lecture we will discuss on the various states of process. New state, ready, running, suspended means waiting, and terminated. We will discuss thoroughly. Thank you.